My name is Lance Gleason. I'm with a small consultancy, or boutique consultancy called Polyglot Programming. We specialize in Rails development, a bit of Angular, along with wearable prototyping and development and mobile development. I also happen to be the CEO of a small company called Authentication. This is kind of one of our side project companies at this point, where we're doing web analytics in physical spaces with things like beacons. So if anything IoT related interests you, probably have a beer or something, it's fun stuff to discuss. I also happen to be the co-organizer of Ruby Fusa, which is, up until this year, has been the only Ruby developer conference in Africa. There now is also a small one in Nairobi, which makes us extremely happy because we love spreading Ruby love. Also, am co-organizer of Ruby DCamp ZA. Now, has anybody here in this room ever heard of Ruby DCamp? Okay, so if you're curious to know what Ruby DCamp ZA is, either come talk to me afterwards, it's an unconference, or talk to somebody that's actually been to Ruby DCamp, because that is how we started this. Quick question for everybody though. How many people here in this room have ever heard of extreme programming? Okay, so pretty much everyone. And how about pair programming? Okay, good number. Awesome. Okay, how many people on a regular basis practice pair programming? Okay, so a decent number. Well, with us being a boutique consultancy, I was trying to figure out one time, how do we maintain the benefits of pair programming when we're faced with some constraints you may not be with a large organization? Like, you may not have a budget for a dev pair, you may not have, there just may not be enough people. And so one day I looked over, and I saw this. How many people here have a cat? Decent number. I thought, what if we took extreme programming to the next level and substituted out a human dev pair for a feline dev pair and practiced her programming? So here we are, we're getting ready for a standard session here. I'm going to kind of do this a little bit backwards, but I've got a comfortable chair for my dev partner, and we're using the single keyboard approach. I've learned a few things with this. I've learned that, first of all, with a cat, like, I used to think that when Allie would jump up on my keyboard, she was trying to tell me, you just want attention. But really, she's trying to tell me, you're doing something stupid, stop that. And as I've talked about this, it's like there are a lot of misconceptions around it. Some people say, well, the cat is always the observer, right? And it's like rubber duck programming. I disagree. She draws, and her code works. This was a gnarly debugging session we were working on this, on a really tough problem, and she helped us through this. Now, how many of you are dog people? Okay, we have run some experiments with canine coding too. Here's Max. He was solving a Ruby problem. And there's our other one, Ming. He was solving another issue, working on some YAML files and all that. And we have here's our interspecies sprint planning session. As you can probably see here though, I don't know, we have Shih Tzus, and the Shih Tzus don't seem to have as much motivation as the cat does. The cat is definitely the lead, the team lead, both from a tech standpoint and just from motivation. So it's definitely something though you should try. We've got a little website for it. I also happen to have t-shirts later on, so if somebody, if you're into per programming, we've got little t-shirts that talk about that, so come see me afterwards. But we're obviously not here to talk about per programming and all that. We're here to talk about web services, and specifically microservices. And now, I wasn't here earlier to see DHH's talk, but I heard that there was some rumblings about maybe the DHH was saying we're using too many of them. If you subscribe to that, you may think that this is, you may not like this talk, but bear with us. And specifically when we're talking about federating OAuth, we're going to talk about a few things. We're going to talk about web services. We're going to talk about federation. We're going to talk about security. And we're going to talk about OAuth. Now, in a way, it's almost feels like it's a little novel, right? We've got the dual stack ace dude, right? We've got the Federation, we've got Ward, we've got the other. Okay. So let's start, though, by talking about services. What are they? I guess the first question is, how many people in this room have ever worked, or how many people here understand what web services are, or feel like they kind of do? Okay, so a few. And then, how many people here have worked in a system where you're working in some sort of a service-based architecture? Okay, so a few. For those that haven't, the best explanation I can give you for what a service is it's sort of an evolution of your platform. And let me explain what I mean by that. You start off with this little Rails application, just like a puppy. Or maybe it's like a kid if you're into kids. But then over time it grows and it kind of gets like a lion. Or maybe a better example is it starts off like Mr. Hanky, where he's friendly, he leaves little brown spots, but it's small and it's manageable and everything like that. Pretty soon it grows and you end up with like, a shit demon or something. And then it ends up with something like this. And you're like, you kind of do something to break it up. So it's kind of, I've very shamelessly stolen this slide, but the idea is it's basically taking a big monolith and breaking it up. You might say, why are you using poop for an example, this one? Well, because there are two types of engineers. There are the ones that have this happen from time to time, and there are the ones that lie about it, right? Now, yes, if it was somebody else's code, where hopefully we have some empathy and we're saying, okay, there's probably a good reason for it because I've done this myself, but that's the idea behind it. Okay, so why do we want to even break up our application? Before we talk about federation, why do we even care about this? Well, usually something's kind of leading us to that point. The monolith is kind of getting pretty unwieldy. It's getting really difficult to make changes because it's just too big. So it feels like this dude here. Our app may be starting to get really slow. Or maybe that we need to scale. We need to be able to scale to certain things to kind of be able to hit the dials appropriately. Okay. How about federation? So we're talking about federation and federating these OAuth services. So what is federation? Well, the textbook definition is basically, it's taking disparate systems and using a common interface so that the disparate systems act as one system. An example of that might be that you have something like this, where you're doing SSO, you want to federate something with a single sign-on solution, and have that single sign-on solution work across multiple sub-services. Okay, so single sign-on. This was one of the impetuses of how this talk came about, because basically we had an application where we wanted to implement single sign-on. Now, when we're getting to that, though, let's also understand a bit about security. Now, security, when we think about that, we think about a lot of different things. And you think about, well, it means nobody can enter my application. The first thing, obviously, we want to understand with that is that there is no such thing as an application that is not 100% secure. Just like when they have safes, for example, safes are rated by the amount of time it will take an experienced safe cracker to get into the thing. So, classic example of that might be that your Wi-Fi network, for example. When you have a Wi-Fi network, you think, it's fairly secure or whatever else like that. But yet, you could do something like basically take a spark cord, a few different pieces, and then put it on your cat and go war diving. There was actually about a year ago a guy who did this. It was awesome. He used his cat to send his cat around to war dive the neighbor's Wi-Fi networks and was able to tell which ones were insecure. Fun stuff. And if you have an adept hacker, like my programming partner here, they can get into your system too. But if we're working with a Rails application idea, we're going to probably use something like Devise. That's usually our go-to solution when we're just adding some security, like we need to log into our application or do something else like that with it. Now, how many people here have used Devise? Pretty much everybody, right? Now, yes, you may use Word. Yes, you may use some custom solution, but for most of us, we're probably going to use Devise. And if we're federating our application, the problem is it's great via the monolith. We just put Devise on there, awesome, done. But if we're not just going to a service-oriented architecture, we were to just use Devise as our mechanism for protecting these disparate resources now, you're going to end up with something that probably feels kind of like that. You're going to have basically multiple instances of your application that are going to either have the same password you have to basically coordinate, or you're going to have a bunch of different passwords and people will probably choose something insecure and you'll have something like that. These are great passwords, by the way, too. You should use them for all your accounts. Some other options that we may have as a Rails developer. SAML. Now, how many people here have ever worked with SAML in your application? So a few. It's not a bad solution. It tends to be used more with enterprise types of implementations. Healthcare systems like them, some banking systems like them. And again, I've seen telecommunications, that type of thing. And I worked with it too, but when we were looking at doing a fresh implementation, my biggest thing that I had trouble getting over was this. I don't like XML. And SAML felt, my first just initial reaction, which may not be the right one, was to say, oh, it feels kind of a little bit like this, or maybe more appropriately, implementing SAML feels a bit like that. Now, how many people here that work with SAML feel like this is what it's like to, yeah, exactly. It's not even, and that's the point. Now, we could, as a Rails developer, always just roll our own security solution as we're federating. How many people here are working in a service-oriented architecture currently? Is anybody? Okay, a few. And out of that number, if you have security requirements, how many people have just decided the hell with these standards, we're going to do it ourselves? Just roll our own. Okay, not many. That's probably a good thing, actually. The other approach we may have heard of is using a firewall. So what do I mean by that? How do we use that to protect our resources and protect our system? Well, in essence, what we have is you've got only one set of ports that's accessible to the outside world. The rest is not. And then you take in that tier and you put authorization and authentication there. So basically at that point, to enter into any piece of the application, you always have to go through this web tier, and that will determine, do you need to authorize to get to the resource? And if you do you have the right permissions? Knowing that doesn't let you through. To kind of give you a little bit of a better example, this is how it might look if you've got your services built out a little bit. So the idea is here that you have an authentication, authorization layer in there, and you have to go through there to access anything else as a standard user. This isn't a bad solution per se, but it's got a few drawbacks. And this is one that we did consider when we were trying to break out our application. The biggest one is that you have a single point of success. Now, this is a nicer way of saying that we have a single point of failure. If you look back at this, every request now has to go through that one layer before it can access anything else in your system. If it goes down, your website goes down. It's bad for mixed use, and I'm going to get into what I mean by that in a minute. And you are adding a layer of complexity to your architecture. Okay, so with all this being said, if you have an application that is very right-centered, and what do I mean by right-centered? Well, you have something like your Wunderlist, or you have a banking application, or you're writing your own version of the web Gmail. That actually may be an appropriate architecture. And if that's the case, probably this federation that we're going to talk about may not be the right thing for you. The problem that we had, though, was that we were working with a property that had mostly read-only content. I would say roughly 90% of the content on this website is read-only. So we're talking about serving up video assets, serving up articles, news articles, that type of thing. In addition to that, only about half of the assets on the website actually require some sort of authentication or authorization. So again, we were looking at this single point of success going, does that make sense for us? The answer was for us, we said, no, it doesn't. Because now, if that one layer goes down, we get a spike in traffic, the whole website just went down again. Now, yes, you could CloudFront, you could come up with some other things with it, but we said, let's keep that layer out of our architecture. Now, the other big thing with this too is we didn't have insane security requirements. We're not dealing here with a HIPAA compliant website or something that needed to be PCI compliant or that's dealing with highly valuable information. It's more subscription based, where if the website gets hacked, if somebody hacks around this authentication mechanism, it's not the end of the world. It will cost the company money, but you could recover. But more importantly too, we needed to scale. This particular website would get spikes in traffic that would easily hit 30,000 uniques. When I say 30,000 uniques, I'm talking, 30,000 concurrents requests. So let's talk about OAuth a little bit. How many people here have actually worked with OAuth? Some way, shape, or form, okay. All right. Now, out of that group, how many of you have actually implemented an OAuth done a server-side OAuth implementation? Okay, so a few. A lot of us probably do the client side, but we don't do the server side as much. Now, there are a number of different, basically, workflows with it. And the biggest one is probably like the web authentication token, I think, or something like that. Or, as I like to refer to it, sometimes it's like the bearer token method. Now, what do I mean by bearer token? Well, it's not a token with Smokey the Bearer. That was my first thing when I saw it, right? Or, a token from your local casino. We're talking about a workflow for authorization. All right, so let's just trace through this for those that kind of have never used this or don't understand. So this will be your typical, let's try to explain OAuth. It basically starts out with, when you've got a user and they say, I want to use this application somewhere. And the request goes from the application over to the OAuth server saying, hey, the user wants to use me. Cool. So a redirect occurs where basically it sends the user off somewhere else to be able to check to see if you actually want to authorize them to use it. It could be just a straight login page, or what most people are familiar with is, hey, you're going to log in through Twitter, and this application is asking if you can log in through Twitter. You want to allow it to access stuff. You allow it. You say yes, and an auth code is returned. Now, a key thing to understand with this workflow is when the auth code is returned, it's actually done as part of the URL in the redirect. And so what's important with that with the bearer token workflow, which is the one we ended up using, the one a lot of people use, is that because it's been returned in the URL, it's not overly secure. And so most implementations will basically, they'll have a timeout of some sort where it's only valid for a very short period of time, and it's a one use. So then it's going to be very difficult for somebody to try to sniff the wire while you're doing that and hack you. From there, another request is made to the OAuth server to say, hey, give me the access token based on this auth code. The access token is given back. And from there, as long as basically everything is kosher, from there we access our service, we pass in the access token, and providing that we have the proper permissions and things like that, we're allowed to use. If you're a Rails developer, this is probably your go-to solution if you're basically implementing your own OAuth provider service. How many people have used Doorkeeper? Okay, so a decent number. Let's look at what it takes to actually use Doorkeeper to put it on one of our services. We're going to do gem, right? The gem, our gem file. We're going to Rails generate, Doorkeeper install, pretty standard stuff. And then we're going to do a Rails generate Doorkeeper migration and a DB migrate. Now, when you're working with a monolithic application, probably none of this would even raise any red flags for you. Because you're saying, well, okay, I already have a data store, so what's this few extra fields in the database? But when you're working with a service-oriented architecture, you may find that when you're breaking certain components out that until you introduce Doorkeeper, you didn't need to have a data store, yet now, if you've got Doorkeeper and you're using that as your OAuth solution, every instance, in other words, every service now has to have a data store. Okay, so we go on through, we're trying to figure out now, okay, we're federating the system, we're trying to break it out. So we've looked at Doorkeeper, we're saying, okay, we like that, we want to use it, but what are some other just basic options? So we may just say, well, let's just sort of eyes on that. Well, actually, we're going to use Doorkeeper with it, along with Devise, and put that on every service. You're still going to end up with the same thing as if you just use Devise without Doorkeeper. Lots of passwords, and let's say if you have 4 services, this is basically the workflow that all of your clients are going to have to use with every one of these services, which from a federation standpoint is not great because, yeah, they kind of work the same, but it's also really clunky. So how do we improve this? How do we basically get this to something that's a little bit more tenable? You might decide with Doorkeeper to use your own authentication mechanism. Yeah, you can throw clearance in there, something like that. It's really not going to help you. You're going to end up with the same situation. Lots of federation, lots of different services. So you could say, okay, let's use the Doorkeeper mechanism to specify our authenticator, and we could have some sort of a call that goes to this. And it begins to help us. However, what we found when we were implementing our solution was that it was kind of, quite often you end up having to have callbacks anyways when you're going out to another service to log in via Devise or something else like that. So we ended up going with OAuth. How many people here have used OAuth? Okay, so a few. For those that don't know what it is, OAuth is basically, it's a solution that allows you to easily hook in other authentication mechanisms into your application. And there's a really nice plugin that allows OAuth and Doorkeeper to work together. So by doing that, we end up with an architecture that looks something like this. And so the idea behind this here is that we basically have, now we've separated out where our, basically our authorization when we log in is off on a separate service here too, right? We still have Doorkeeper on all of our other services, our microservices. But at least we're not having to maintain multiple passwords for the application. Now Doorkeeper is going off to a central server somewhere to at least log in. And from a usability standpoint, this actually might be enough for a lot of applications. We say, this is good enough. It's actually usable enough. And in fact, about a year ago when we started this project, this is where we were at. This was the best thing that was out there when we did a bunch of research, especially in Ruby code. They were saying basically, oh, if you need to federate your OAuth services, go and install Doorkeeper on every single one of the services, and then just use your centralized login solution, and there you go, that's it. Your implementation, it might look something like this, where you basically, basically with OAuth, what you do is you create a module that's overriding with the strategies, and you do an autoload inside of there. And you might have various things like Vulkan service, Klingon service. I just made up some. And then you configure OAuth to use basically those providers. And then a strategy implementation may look something like this. So you basically, the big thing to note with this when you're doing it is you've got a request phase and a callback phase. And so in the request phase, you're going to set up some things, and then when you make a call over to whatever service you're going to log into, the user's going to log into rather, you're going to have something you're going to tell it where to call back to and what to send it. Then when you get your callback page, you're going to process it, were they successful, and then send them on and give them an auth code. If you're not federating a lot of services, it's fine, because you'll just have to deal with maybe one token. But when you start to get a lot of services, you'll end up really quickly having to manage all these different tokens in your client. And when we looked at this, I said, this was my reaction. I wrote that. It's like, why the hell do I have to manage all these tokens? Because the problem is you start adding services, and now you're going to have to take in, you're going to have to manage a logout. You're going to have to somehow figure out a way to destroy the tokens. You're going to have to invalidate them. You're going to have to go back to all the services. And it's like, that just didn't quite feel right. And when you're working with a service-oriented architecture, these are a lot of common patterns you're going to run into, where it's like basically you're saying, oh my god, Okay, initially we had one problem, but then we start pushing the problem around. Okay. What if we do a little bit of delegation and make our architecture look something like this? So the big difference here is that instead of having basically every single one of these services having divide as first identifies having Doorkeeper on them, what if we put Doorkeeper on just one of them here? And then delegate calls from our other services over to that one. And in an ideal sense, if you're really following textbook microservices architectures, you're going to basically Doorkeeper, that service will then become something that only processes OAuth style requests. When I say that, meaning it's handling, it's just got Doorkeeper on there, and its whole mission is just managing that OAuth lifecycle. You still have some other services dedicated to logging in, out. And then other services in the system basically delegate calls over to Doorkeeper. How does that look? In essence, what we have here is now on our non-Doorkeeper service, we no longer need to install the Doorkeeper gem. We no longer have to have a database. What we do instead is we basically, in our application controller, and this is very similar to what we actually ended up putting in production. We just basically say, okay, great. Let's take and let's create a small filter. And you just put a before filter in your controllers. And if you look, all we're doing with that one is we're saying we're looking at the header. And this is just standard OAuth, where basically, as part of the standard, you put in that request header an authorization token. It sits there under authorization. We look at that, and then providing it's there, send a request through to our Doorkeeper service to see if they're basically authorized or not. We may send some metadata back, and providing that everything works, we let them through. And if it doesn't, if either the user is not authorized, or it's an invalid token, or something else like that, we 401 them. And from there, all the requests to either, the user can then, via the client, the standards that OAuth provides, it can either go through and say, we're going to now go back and we need to refresh our token, or maybe we need to log in, or do something like that. We still have a problem with single point of success with this. We're doing better. If you look back at this now, especially with the architecture that we have for this application, 50% of the reads needed to go directly to the services and didn't require authentication, but the other 50% did not. So we have a bottleneck where every single time something requires authentication, it's still going back to Doorkeeper to see the service that has Doorkeeper to see if they can get in or not. So under load, obviously that's going to cause a problem for us. So what if we try something a little bit different? We do some cache delegation. Now, to be honest with you, I'm not even sure if this is an official term or not, but this is kind of what we ended up calling it. So what do I mean by cache delegation? Oh, that's right. That was the first thing that came to mind. I was like, I gotta put that on. But what we actually mean is this. Our architecture looks very similar to how it was before. But the difference is now we've added another layer. Or not a layer really, but we've just added one little thing to our services, and that is that we're caching the tokens now in each one of these services. So the idea behind this is that basically, instead of just sending the requests all the time back to Doorkeeper, our Doorkeeper service, we say, hang on a second. If we've already received a request with the same token that we're receiving right now, and it's within a certain period of time, just let them through. We throw an in-memory database on the services, and now, in essence, what we have is we've kind of got the best of both worlds, where we have one service whose primary mission now is just to take care of OAuth requests and handle all the OAuth stuff. We have another service that's only dedicated to one thing and one thing only in life, and that is handling login, basically authentication and all that. And then our other services only have to concentrate on what they're designed for. Our implementation may look something like this. And again, this is actually very similar to what we're actually using in production on the system. And you'll notice the only difference is you just have a Redis, you have to check in Redis first to see if we've seen that token before. And then we check to see if it's expired yet. And if it has, we let them through. Otherwise, we don't. Everything else is exactly the same. With this solution, when we load tested, we're in production right now. We can get spikes worth of 30,000 concurrents, and the thing doesn't even break out a sweat. When we've run this through things like Blitz and stuff like that, we've been able to get much higher numbers, and so we feel very confident that this will scale. And it has so far. And compared to our monolithic application, this did work for us. So success. This is how we solve this problem. Now, with that being said, a few reflections on this, I guess, are in order. Because we're obviously talking about OAuth. Okay, great. How do we take and scale this thing and everything? But I don't know. Out of the people here that use OAuth, how many people really enjoy the process? How many people really enjoy using OAuth? More importantly, how many people found that it was easy to use? One person, right? That's exactly it. So we have a sadomasochist up in the front. Other than that, nobody does, right? And that's been the exact experience. And so every time that I've had to go in and look at this after the fact, a couple months after, 2 months after we first implemented, we have to tweak a couple things or whatever, or we need to add another service to it, I always feel like this. This is honest to God. I mean, even after being pretty deep in this and doing a hell of a lot of research, and granted, yes, I'm not a security expert or anything like that, I come back and I go, God, this is so painful. Now, yes, somebody can say, yeah, but it's a standard. You hear that sometimes, and then I've heard people suggest, well, maybe we could just use basically JSON web tokens. That might be something. Let's say if you roll your own solution, it's going to be less secure. And actually, overall, I would agree with that. Minus, with the one caveat being, unless you know what the hell you're doing and you're a security expert, then you probably would roll something better than some of these solutions. It's not anything against the team that's developed Doorkeeper, OAuth, or anything else like that, but it's kind of one of those things where it becomes a standard. But keep in mind, Java web tokens and things like that are also really early. Probably the other biggest thing that we found was that default Doorkeeper could be extremely insecure too. And let me explain how this has happened, because we actually did have this occur. Bad confessional, but luckily nobody knows which sites this was on. When we did our first implementation using, basically creating an OAuth service with Doorkeeper, Doorkeeper gives you this really nice sort of web interface, right? And you can basically create new authorization tokens with it, and do different things like that. And you'll get, what we found is we had that, we looked at that, and then decided to go with a different mechanism for it. And said, okay, great. Let that go, did the rest of our implementation, and forgot to turn that off. And so for about a month, it's sitting there in production, and luckily the users for this website are not that sophisticated. We don't have any evidence that anybody actually got in and did anything with it. Damn it, shut it off. But it's real easy to do. And that's probably one of my biggest takeaways in general, probably the biggest, if you were to do a retrospective on this, is that this is what it feels like when you're trying to put security into a federated application. It feels like you're trying to create a lock, and they're giving you this. Okay, go create a lock with that one. Well, I'm not a freaking locksmith, right? I don't know about that. I just want to secure my thing. I just want this. I want to be able to just install it in a house like this and have something I can use. But it's just so often, it's like, and it's not, right now, OAuth, I think, is one of the better solutions with it. I wish there was something better, but it was like the best people that we had. But it makes me wonder if there is something better. But, maybe it is we just need to evolve things, because unfortunately, unless you're a security expert, it's going to be probably really easy to add a lot of holes to your application. And if you have something that has heavy security concerns with it, where you might want to use something that's more federated, it's going to be really difficult to best. So, at any rate, that's all I have. Open the floor to some questions here.